I am Dr. Binu. In digital signal processing, the second topic in the fourth unit is ADC. What is meant by ADC? It is an analog to digital converter, which is an electronic component that converts continuous real-time analog signals like voltage, sound, temperature, or light, or whatever may be the real-time signals into discrete digital signals, that is zeros and ones, that computers and microcontrollers can process. It acts as a translator for digital system to understand environmental data. How an electronic ADC works. The conversion process typically involves three primary stages. First one is sampling, second one quantization, third one encoding. Sampling means measuring the analog signal's value at regular intervals. That is called as sampling rate. Quantization, mapping each sample to the nearest level in a finite set of digital values. Encoding, converting these levels into binary code, that is ones and zeros, that a microprocessor can read. What is meant by quantization? Quantization is the process of mapping input values from a large continuous set to a smaller finite set of discrete values. It is widely used to reduce the precision of digital signals, convert analog to digital signals, and compress machine learning models to improve efficiency, speed, and memory usage, often with minimal loss in accuracy. This graph represents the original signal, quantized signal, and quantization noise. What is meant by quantization noise? Means the difference between original signal and the quantized signal. There are varieties of methods are used for quantization. First one, rounding and truncation. This is the basic numerical methods for mapping values into nearest integer. Second, dynamic versus static quantization. In static quantization, which calibrates the range of activations beforehand, while dynamic quantization determines the range on the fly during inference. Third one is uniform versus non-uniform. Uniform quantizers divide the range into equal steps, whereas non-uniform quantizers use uneven steps to prioritize accuracy for specific ranges. Methods of quantization. The important or significant methods used for quantization are truncation and rounding. Quantization reduces memory and computational cost, allowing large models to run on edge devices or CPU. Quantization error or noise is the distortion introduced by the precision loss. The key applications of quantization are, which is normally used in machine learning and AI, signal processing, physics, and music. Truncation and rounding. What is meant by truncation? It cuts off digits after a certain point regardless of value. That is, 3.49 is truncated means it becomes 3.4. Whereas rounding adjusts the final digit based on the next digit's value. Typically, rounding up if 5 or higher values. That is, 3.49 becomes 3.5. Truncation is faster but less accurate. Rounding provides closer approximation. Truncation simply chops off digits at a specified decimal place, ignoring subsequent digits. Rounding selects the closest finite number with a specified precision. If the next digit is 5 or greater, the last kept digit increased by 1. What is the usage of truncation and rounding in computation? Truncation, often used in computer integer division where the decimal part is discarded. Rounding is crucial in numerical methods and signal processing to reduce errors between true values and finite precision representation. Quantization errors are the differences between original continuous time analog signals and digitized discrete representation arising from rounding or truncation in analog to digital converters. Quantization noise is unavoidable error in DSP arising when continuous signals are mapped to discrete digital levels, creating a rounding error that behaves like random additive noise. The noise bar can be represented by q square divided by 12. Here q is the step size. The quantization error is represented in this diagram. Quantization noise can be calculated using various steps. The quantization error can be represented in the equation format E of n is equal to xq of n minus x of n. Quantization forms can be represented by rounding, 2's complement truncation, magnitude truncation. In quantization form, in rounding is represented by E of n is lies between plus q by 2 to minus q by 2. Finite word length effect. In truncation, E of n is lies between minus q to 0. Quantization noise bar in rounding of method, sigma e square is equal to e to the power of e square n minus e square into the power of n, that is q square by 12. The noise bar is equal to 2 to the power of minus 2b by 12. In truncation, the formula is represented by q e square is equal to 1 by q integral of minus q to 0 e square n dE. Noise bar equation is seen in quantization as well as truncation, that is rounding as well as truncation. Key aspects of quantization noise are: it occurs in ADC, it produces audible keys in audio, image artifacts, and reduced signal precision. It is quantized by signal to noise ratio, that is SNR, with noise increasing for lower amplitude signals. Increasing the bit depth of ADC reduces noise as each additional bit improves SNR by roughly. Common effects in DSP system: efficient quantization, product quantization, and nonlinear effects. Thank you.